Hello, my name is Nikita and I'm a field application engineer for digital and optical products here in Anritsu. And today I'd like to talk a bit about 5G networks. And as you know, in 5G networks, one of the most interesting application is the machine-to-machine communication. And if we really want to have this fully automated vehicles or surgeon robotics or drone logistics, there is a critical need for ultra-reliable low latency. So currently we all measure latency using ping, but ping actually has two issues. So first one, it's very dependent on the service that you are using, because you never know when and how fast it will reply to you. And the second issue is that this is actually the rough approximation, because the ping is the round trip measurements. So we simply approximate that the latency, one-way latency, downlink or uplink, is the we take the ping and divide it by 2. So in order to have this accurate latency measurement, we have a solution. So here you can see the MT1000A. This is a user equipment, and it's connected to the 5G mobile router, and we have the same setup on the far end, the server side in the lab in the UK, which is also the remotely connected MT1000A with the 5G mobile router. So they are talking to each other via mobile 5G mobile network. And the server side, since both of the instruments are synchronized with GPS, the server side sends the frames with the timestamps, and the user equipment can actually calculates the latency. So we can see here that this is the downlink latency. We can see here an average latency around 50 milliseconds. But if we look onto uplink latency, we will see here around 60. So that means that the actual latency, the downlink and uplink, are really asymmetry, even if it's the same path. So apart from the latency measurements, in addition to the standard measurements, we can also show this on the map. So here is the buildings where we are now, and if I can zoom in, I can actually point and look into each of the measurements and find out for example, the red one, the worst one. I can click on it and I can see all the results, like throughput, like loss frame or average latency, but I can see that maximum latency is around 170, meaning that most probably that was the handover from one base station to the other base station. So as you can see, this is the best solution for measuring the low latency 5G networks. Thank you. Thanks for watching.